I'll have the review. This is the mid-test 4 review. Notice it's from 4.4, 4.0 to 4.4. So let's kind of go over this stuff really quickly. We won't take too long. Most of this stuff you guys practiced already, so let's just go through it real quick, okay? So number one, I want you guys to notice that there is a plus sign right there, okay? So the fact that there's a plus sign there means you don't multiply these together. You're just going to kind of add them together. So you have negative 1 minus 4i minus 6 minus 5i. Now get your numbers together. Negative 1 minus 6, that's negative 7. Now notice, guys, at that point, I should already know that this is my answer, because none of the other options have a negative 7 as the number. Okay, but if we continue, negative 4 minus 5, that'd be negative 9i, and now you have, for certain, you have the right answer, okay? So that would be that one. Well, you do have to distribute that plus, so a positive times a negative would be negative for the 6, so it stays negative, and a positive times a negative for the 5 would make it negative anyway. Yeah, and the reason why I mentioned that is because if there's a minus sign in the test for you guys on Friday, it's going to change all the symbols for the stuff after it, right? So you got to be careful with that. Now, number 2 is something I saw a lot of you guys miss on the group test, okay? So I want to make sure you guys remember this thing. So when we're doing questions like number 2, you're going to multiply these two together, okay, first. So you're going to get a negative 2i squared. Now, a lot of you guys did not, and let me write this part right here. A lot of you guys did not change the I squared to a negative 1. Remember, there's a definition that says I squared equals negative 1. A lot of you guys didn't do that, and then you multiplied again. You ended up with I cubed, and your answers came out incorrect, okay? You have to change it. So right now, that negative 2i squared actually is a positive 2. Okay, so instead of negative 2i squared, you should have a positive 2. And then distribute that in. So that's going to be 14 plus 10i. So that's going to be C. But yeah, a lot of people missed this on the group test. I know a lot of people got it right too, but there was a lot of people that left it like I cubed and stuff like that. They forgot that I squared equals negative 1. So, you know, when you guys make your little cheat sheet 3x5 inch card, write these things down, okay? Highlight these things. You know, I noticed when I look at a lot of you guys, when you're taking the test and you have your little note card, it's basically like a piece of paper with a bunch of pencil writing everywhere, okay? Not that that's bad, but if you don't highlight something or underline and stuff like that, or organize it in a certain way so it's faster for you to find it, then you're always just searching, okay? This is why I never do open note tests, because if I do an open note test, you guys would like be like, yeah, that's awesome. On average, what ends up happening in a 1 hour period is students in my math 1, 2, and 3 classes will search for work or answers for 30 minutes and only work on the test for 30 minutes. They always run out of time because, number one, they didn't study, so they didn't practice, right? So now they're hoping they can find the solutions in their notes, but since their notes haven't been looked at because they didn't study, they don't know where to look for anything, right? I've seen some of you guys on your notes, you guys put little stickers, which is a great idea. You put like section 3.1, section 3.2, section 3.3. I've seen some people put little tabs and they'll put 3.1 and then they even write the topic that it is. Okay? Some people put little tabs and on the side they put the important things like quadratic formula, I definitions. So they know like, oh, that's where I need to go right away. Okay? If you organize your stuff, it's a lot easier to find things. But yeah, that's the reason why I don't do open note tests. Not because I don't want to. I mean, I'd love to. But the thing is, more people fail those tests because they're too busy looking for stuff. And they run out of time. So it's better to give you just a little bit. But if you have just a little bit, make sure you guys highlight, it's useful for you guys to do it. So let me just make this thing disappear. I'm not sure why it's doing that, but All right, there we go. All right, number 3. Remember, we're trying to do about 9 of them today. This one requires you to distribute, okay? You're going to distribute this first, okay? And then you're going to distribute this after. So just be careful when you do it. So we have a negative 4 times negative 4, that's 16. Negative 4 times negative 3, that's positive 12i. An 8i times a negative 4, that's a negative 32i. And then an 8i times a negative 3i, that's a negative 24i squared. Now remember, I squared means negative 1. So that negative 24i squared is actually a plus 24. Okay, so let me write that out. 16, 12 minus 32, that's negative 20i plus 24. Okay, to get the negative 20i, I got 12 minus 32, right? So negative 20. 16 plus 24, that's 40, minus 20i, so your solution will be D. By the way, your test, I think the first, I might be wrong, but the first 7 or 8 are multiple choice, and then the rest are like open-ended, okay? So kind of like what we're doing here, there's going to be multiple choice on the test as well. Now, for number 4, you're going to have to multiply by the conjugate of this thing. Okay, so in our case, we have division by a negative 6i. So let me write this down real quick. 6 plus 5i over negative 6i. So you could multiply both top and bottom by the conjugate of negative 6i, which would be positive 6i. Okay, so on top we get 36i plus 30i squared over negative 36i squared. Now notice what I got and then the options. You see how there's like 6s and 5s and 9s? That means they reduced after. Okay, so we're going to have to do the same thing. Now 36i plus 30i squared. 30i squared should actually be a negative 30. Okay, so let me write that right here. Negative 30 plus 36i. And then negative 36i squared should be a positive 36. Okay, so now let's reduce. Okay, let's reduce this thing here. Did I do that? I did do that right? I'm just looking. 30i squared, 36i. All right, so let's see. What can I divide 30 and 36 by?
3.
By 3, I can go bigger.
9.
By 6, right? I can go by 6. So negative 30 divided by 6 will be negative 5. 36 divided by 6 would be 6i. And 36 divided by 6 would be 6. Okay? So which one is the right answer? B, which is actually written incorrectly. I don't like that, but it is right. I don't like the fact that the I is in the front, but it is correct. Okay? So that would be number 4. Now, number 5 is a little bit more complicated, so we might have to kind of move around a little bit, but I'm going to have to multiply by the conjugate. Now, the conjugate of the denominator for 8 plus 5i is 8 minus 5i. Remember, conjugate just means to take the opposite of the complex number. Now, we are going to just distribute like we normally would. So let's see. 5i times 8, that's 40i. And 5i times negative 5i would be a negative 25i squared. Now on the bottom, do you notice how the bottom is a difference of 2 squares? Is it a plus b, a minus b type of multiplication? I don't know if you guys see that. So that just means that the middle terms will cancel, just so you know, okay? So let's multiply 8 times 8, that's 64. 8 times negative 5 is negative 40i. And then 5i times 8, that's positive 40i. And 5i times negative 5i, that's a negative 25i squared. Again, middle terms will cancel out. So let's clean up what I have here. I have a 40i plus 25 because negative 25i squared becomes a negative 25 times a negative 1. So that's a positive 25. On the bottom, I get 64 plus 25. Now, 64 plus 25, that's 89. I got 40i plus 25. I guess you can find your answer right now without reducing. It's part A. Now you can see 6 says solve using the quadratic formula. Okay, so we're going to have to do that. But before I do that, any questions on 1 through 5? Remember, what I want you guys to do today for homework is to go over these again. Okay? I am going to send you guys a clean copy of this through the email. You'll have a little PDF you can click on if you want to print it out at home so it starts brand new and you just start working on it there. That's fine. If you just want to write out the problems again on a piece of paper, that's fine too.
On 5,
Uh-huh.
how come you wrote 8 minus 5i if there's no minus sign?
Oh, it's because since right here, let me highlight this right here, you're not supposed to have square roots in a denominator. The letter I is square root of negative 1. I'll write it right here just as a reminder. So that means there's a square root in the denominator. So the way we get rid of complex numbers in the denominator is we multiply by the complex number 8 and 5i, but we change the sign in the middle. So instead of a plus, we write minus. And that allows us to notice how there's no more I values in the bottom. That allows us to get rid of it. So that's called the conjugate, the complex conjugate, actually. So that's in our notes as well. So let's do this next one, okay? So we have to do this using the quadratic formula. In order to set something up for the quadratic formula, I got to make everything equal to 0. So I'm going to have to move all this stuff over. So when I move the 8n squared here and I move the positive 5n to the left, it becomes a negative 5n. And when I move the negative 4 to the left, it becomes a plus 4. And I get 0. Okay? So 8n squared minus 5n plus 4, that's my equation. So that means that A is equal to 8, B is equal to negative 5, and C is equal to 4. My formula, I know it says x equal to, but I'm going to, normally we write x. I'm going to write n equals to, because that's my variable. N equals to. Negative b plus or minus the square root of b squared minus 4ac over 2a. So that's a good equation to write down in your notes in case you don't know it by memory. So negative b, that's a positive 5, because b is already negative. So they want us to make a negative again, it'd become positive. Plus or minus. Now notice, are there any options I can eliminate right now as not being the right answers? A and what else? And B, right? B is kind of questionable, but I would say maybe we could. I'm going to leave B there because I don't know if maybe, whatever I add or subtract is going to add up to 4 eventually, so I'm not sure. But I can tell you for a fact that the 5 has to be positive up there, so it shouldn't be negative like it says in A. All right, so that's one thing I kind of noticed. Let's see, square root of b squared, that's 25 minus 4 times a times c, that's 8 times 4 over 2 times a is 8, so that's 16. They all have 16 on the bottom, so we're okay. The top part, 32 times 4, let's see, 32 times 4, that's an 8, that's 128. Okay, so this is 5 plus or minus the square root of 25 minus 128 over 16. Can you tell that I'm going to have a negative number inside my square root? Right? 25 minus 128 should be a negative number. And if there's a negative number, that means there has to be imaginary, right? An imaginary answer. So that means B cannot be that answer. Can C be the answer? Do you see an imaginary root anywhere on C?
No.
No. This can't be the answer. So the only answer is D. Let's just finish it up to prove it. But, I mean, notice how, guys, I don't do the whole problem. I'm thinking my way through it, because why am I going to do all the work if I could figure it out, right? You guys have heard the whole work smarter, not harder thing, right? Be smart about what you do. You have multiple choice, so you can eliminate stuff if it doesn't make sense, right? So I didn't even finish the problem, but we'll go to it right now. N is equal to 5 plus or minus the square root of negative 103 over 16. Since it's a negative number, then I get to take out an I value for it. So N is equal to 5 plus or minus I square root of 103 over 16. Now, 103 is a prime number, so you're not going to be able to break it down, okay? So my answer is D. So there will be a question like this, like everything we're doing right now, this review, notice it's made on a computer. That means that all we did was we created the original test. We said, okay, save that file. We're going to call that the mid-test test or whatever, chapter 4 mid-test. And then we tell the computer, regenerate. And it gives us all new problems. It doesn't change the type of problem. It just gives us new numbers. Okay? So you're going to see them in this order. Okay? Most likely on the test. And they're going to be the same type of problems. This is why we give you guys these reviews. It's not because we want to make you do extra work. We just want you guys to practice it, and you should do just fine. Okay? From the given polynomial function, answer the questions. So 7a, find the degree. Well, the degree for y equals x cubed minus 3x squared minus x plus 5 is 3. That's the highest degree. Name the polynomial. This is a cubic function. Describe the n behaviors. Well, the n behaviors are based on the degree and on the number in the front, which we actually don't see. It's a positive 1, okay?
How do you know that 3 is the biggest degree?
The highest power. Remember, degree means highest power you see. So if you look at number 7, there's a power of 3, a power of 2, then a 1, and then there's no x right there, right? So the highest power is a power of 3. So the one that I highlighted in yellow. So yeah, that's the highest power. And then based on the highest power, you give it its name. So if the highest power was a 5, you call it a quintic function or degree 5 function. So since this is an odd power with a positive coefficient, that means the graph looks like this. So that means it goes bottom left to top right. Or I think in the test it says like falls to the left, rises to the right. Okay, same thing. No real difference. Now for the next one, what's the highest degree that we see? We see a 4, right? It's kind of hidden in the middle. But there's a 4. And then based on that degree, we look at the number in front of it. That's a negative 3. So let's answer the questions here. The degree is 4. Name the polynomial. It's going to be a quartic function. Or you could just say function of degree 4. But I don't know which options they're going to have for you if you have to pick one. The n behavior, since it's a power of 4 with the negative number in front of it, the graph will look something like this. Okay, now how do I know it looks like that? Well, notice my graph changes direction 3 times, right? It's going up, then down, that's 1, then up, that's 2, then down, that's 3. 3 changes in direction indicates a 4th degree, right? So that's why I know it's going to look something like that. It's pointing down because the 3 is negative in front of it, okay? So we're going to go bottom left to bottom right. Or I think on the test the options will say it falls to the left and falls to the right. Okay. They use rise and fall. All right, so last one, question number 9. And then after that, I mean, if you guys want to go ahead, feel free. But if you want to wait till tomorrow, that's fine. But number 9 says find the degree. Okay? So let's see. It goes down, and then it goes up, then down, then up, then down. So changes in direction would be 1, 2, 3, 4. 4 changes in direction. I know it's kind of... There's 4 changes in direction. So when it goes down, you don't count the initial motion, okay? When it's going down, that doesn't mean direction change. Once it hasn't changed direction, it started going down. So that's its original direction. Then it went up, so that's 1, then down, 2, up, 3, down, 4. So if it's 4 changes in direction, what's its degree?
5th degree.
5, 5th degree. It's always 1 more, right? So we're going to put degree of 5. Then they say, is the leading coefficient, let me get rid of this, is the leading coefficient positive or negative? Well, remember, if it's an odd power, it's either going to look like this, or let's say something like this, okay? The left side is if your A value, your coefficient is positive. The right side is if your A value is negative. Notice how this one right here is rising to the left and falling to the right. That's the same thing that one's doing. It's rising to the left, falling to the right. So this would have to be negative. I'm just going to highlight it. Okay. So those are the first 9 problems. You'll notice like 10 and stuff like that. Remember 10 is the one, I'll just kind of give you guys a heads up here. If you want to try them at home, feel free, okay? But number 10 says, here's a bunch of points. Use finite differences to find the degree of the polynomial. Remember, you're supposed to get these points and put them in a chart and then subtract the y values, and if they all match up, then that means it's a first degree. If it doesn't match up, you subtract again and subtract again until you find that the numbers all match up. However many subtractions that took, that's your degree. So if you subtracted 3 times to get it, then that's a 3rd degree function. If you only did it twice, then it's a 2nd degree function. If you only did it once, it's a 1st degree function. Okay? That's part A. Part B says, what is the average rate of change from -1 to 2? They're basically asking you to find the slope when x is 1 and when x -1 and when x is 2. So find the slope between those two things. That's what average rate of change is. It's just slope. Okay, remember we did the notes, we call it the AROC, right? So you're just finding it between those two. For 11, use the graph to find the average rate of change from -1 to 2. So I would recommend that you mark -1 and 2, write down the actual points that are there and find the slope for that. That's how you find the AROC, okay, the average rate of change. So just put the points on there and then find the values. Again, this is if you want to do it tonight, feel free. If you don't, that's okay. Number 12, consider the function y equals x cubed minus 7. What is the average rate of change between -1 and 3? The way you figure out the points is you plug in -1 into the equation and you solve. That'll be your y value. And then do the same with the 3. Okay, plug in the 3, you'll find your y value. Once you do that, you'll have 2 points, and all you got to do is find the slope again, right? Rate of change is slope. You're just finding slope. 13. Now, this is the one that some of you guys are really good at on the test. Some of you guys had no idea what you were doing, and we will review again tomorrow. But remember, there's notes. There's video of me doing these things. Look them up. They're giving you a piece of cardboard that's 3 by 7. They want you to cut little square corners off, right? You have to write the formula for it, and they want you to multiply it out, and they want you to use Desmos most likely somewhere. Maybe not. Write the volume of the box. Where's the... Oh, so they're telling you for part C, what if x equals 1? So you just plug it in. If x is 1, plug it into your formula. It's going to give you an answer. What's the maximum number of x-intercepts that a degree 3 polynomial may have? So that doesn't even have anything to do with number 13. So they're actually making you do a lot less work for this box problem, just 3 little parts instead of 6. So that's good. Maximum number of x-intercepts for a degree 3. Do you guys know? We can do that right now. We don't have to do that tomorrow. What's the maximum number of x-intercepts? The maximum number of answers that a degree 3 can have?
2, 4.
It's 3.
5.
3 max. 3 max. If you look back at the notes, I wrote it down. I said the maximum number of solutions equals to its degree. Right? Equals to its degree. Now, this next question might be a little more difficult. We'll see. What is the minimum number of x-intercepts that a degree 5 can have? We know it can have as many as 5, right? But then I told you a definition that said it can have 5 or what?
Negative infinity.
It can have 1. That would be right. How did you get it?
Because if you move it down, I don't know.
How many? How many did you move it down? So she's kind of remembering. She has the right answer. She said 1. 1 is right. Do you guys remember the definition? You
Did
can
you
have
add 1 to 4.
or less than by 2. So I got 5. So if I subtract 2, I have 3. If I subtract 2, I have 1. Now if I subtract 2 from 1, I get negative 1. But remember, there was a little thing that said you cannot have negative numbers of solutions. So 1 is the minimum. Okay? So, all right, what is the minimum number of x-intercepts a degree 2 can have? 0, because if you subtract 2, you get 0. As long as you don't have negative numbers, that's fine. So this would be 0. What is the maximum number of y-intercepts that a degree 5 can have? You guys remember? Not 5. 1. Every graph, unless it's a vertical line that's not on the y-axis, every graph can only have, if they call it a function, it can only have 1 y-intercept. Okay? If you look back at the notes of all those graphs we did, right? Remember on Desmos, I was shifting it left and right and up and down, and the number of y-intercepts never changed. Okay? It was always 1. Okay? So look at those videos, but these should be pretty easy. So I guess we did more than I wanted to, but tomorrow we'll go over 10, 11, 12, 13, and that'll be it, okay? If you guys want to do them on your own, feel free.